Right now, somewhere on Earth, a person is dying because they don't have enough water to drink, which is strange because if you looked at the planet from space, water is almost all you would see. 71% of the Earth's surface is covered by oceans. There are roughly 1.3 billion cubic kilometers of water on this planet, and yet less than 1% of it is easily available for humans to drink. Which raises an obvious question. If we've built rockets, artificial intelligence, and machines that can edit DNA itself, why can't we simply take seawater and turn it into drinking water? The answer is that we can. We've known how to do it for decades, and that's exactly what makes the question so interesting. Because the real mystery isn't why we can't, it's why we almost never do. Let's start with the ocean itself. Seawater contains about 35 grams of salt in every liter. Your kidneys can't handle that much. If you drink seawater, your body actually loses more water trying to remove the excess salt than you gained from drinking it. In other words, this ocean is full of water that makes you thirstier. So how do we remove the salt? The oldest method is simple. Boil the water, capture the steam, leave the salt behind. Humans have been doing this for centuries. Sailors did it. Submarines do it. Entire countries do it. Today, a second method dominates. Reverse osmosis. The process sounds complicated, but the idea is simple. Force seawater through an incredibly fine membrane. Water molecules pass through. Salt molecules do not. Out comes fresh water. Problem solved, except not really. Because making fresh water isn't difficult. Making billions of liters cheaply is. And that's where physics enters the conversation. There is no technology that can avoid the laws of thermodynamics. Salt doesn't want to separate from water. Nature mixed them together. And nature charges an energy bill for pulling them apart. No matter how advanced humanity becomes, some minimum amount of energy will always be required. There is no shortcut, no clever invention, no software update. Physics does not negotiate. This is why desalination plants consume enormous amounts of electricity. And electricity costs money, lots of it, which is why countries with abundant energy have embraced desalination more than anyone else. Saudi Arabia, Israel, the United Arab Emirates, Australia. In some places, more than half of the drinking water comes from the sea. So why doesn't everybody just build thousands of these plants? Because desalination creates another problem. Salt has to go somewhere. After extracting the fresh water, what remains is an ultra-concentrated brine, a liquid even saltier than the ocean itself. If released carelessly, it can damage marine ecosystems and suffocate local species. The water problem becomes an environmental problem. And then there is infrastructure. A desalination plant doesn't magically deliver water to your kitchen. Pipes have to be built. Pumps have to run. Reservoirs have to be maintained. Millions of liters have to move every single day. Water is heavy. 1 cubic meter weighs a ton. Moving that weight across entire cities requires huge amounts of energy, and this leads to a strange realization. In many places, fresh water isn't scarce because humans lack technology. It's scarce because transporting and producing it economically is difficult, which explains something that seems almost absurd. Sometimes it's cheaper to recycle wastewater than to desalinate seawater. Cities around the world increasingly clean and reuse water that people have already used once. Not because it's futuristic, because it's efficient. But here's the part most people never think about. Human civilization wasn't built beside oceans. It was built beside rivers, the Nile, the Indus, the Yangtze, the Tigris and Euphrates. For thousands of years, fresh water came almost free. Gravity moved it. Rain replenished it. Nature handled the infrastructure. Modern civilization inherited that gift. And only recently have we begun realizing how valuable that gift really was. Because the age of cheap water may have been the exception, not the rule. Climate change, droughts, and growing populations are placing increasing pressure on rivers and underground aquifers. And as those traditional sources struggle, humanity is turning toward the ocean. Not because desalination is perfect, but because the ocean is the one reservoir that never runs dry. Which brings us back to the original question. Why can't we make seawater drinkable? We can. Thousands of times every day. Millions of people already depend on it. The real question was never whether humanity possessed the technology. It was whether humanity could afford the energy, infrastructure, and environmental cost. For most of history, nature provided fresh water almost for free. And we became so accustomed to that miracle that we stopped noticing it. The ocean contains enough water to supply humanity for millions of years. The problem was never a lack of water. The problem was that the water came with a price tag written by physics. And unlike governments, economies, or civilizations, physics has never cared how badly we want something. It simply presents the bill and waits for us to pay it.